You know that seamless smart home future we were all promised? For years, it's felt more like a mess of gadgets that just refuse to talk to each other. Well, today, we're going to pull back the curtain on the tech that's finally fixing all that. We're going to break down the universal language and the tiny but mighty chip that are making a truly smart home a reality. So let's just start with a question that I'm willing to bet has frustrated every single one of us. You get a cool new smart light bulb, you bring it home, you're all excited, and nope. It just won't talk to the smart speaker you already have. Why? It feels like it should just work. And this isn't some small bug. It's been the single biggest headache holding the entire smart home back for years.
The thing is, for the longest time, the smart home wasn't a friendly neighborhood. It was a battleground. All the big tech companies built their own little fortresses, what we called walled gardens, and they all spoke their own secret languages. This meant your smart lock from company A couldn't understand your thermostat from company B without you buying some extra little translator box. It was confusing, it was expensive, and honestly, it was just plain frustrating for everybody.
So, let's put a name on it. We're talking about the smart home problem. And it was never about a lack of cool ideas or amazing gadgets. The real issue, the one thing holding everything back, was the lack of a common language.
And this image, this says it all, right? On the left, that's the past. A chaotic mess, a tangle of different hubs and protocols, each one shouting at its own language. The dream, the goal, the entire industry has been chasing is what you see on the right. A single, clean, unified network where every device just gets along. And that finally brings us to the solution. The biggest names in the game, we're talking Amazon, Apple, Google, you name it, they finally decided to call a truce. They came together to build a bridge over all those walled gardens. And that bridge has a name, Matter. Okay, so what is Matter really, under the hood? Well, it's an open IPv6-based protocol. Let's just break that down real quick. Open means no single company owns it, it's for everyone. And IPv6-based, that's the important part. It means it's built on the exact same foundation as the internet itself. So think of Matter less like a brand new language and more like a universal translator that just works on top of the networks you already have in your home. And here's the really clever part of its design. Matter doesn't try to replace Wi-Fi or this other cool low-power network called Thread. No, instead, it just makes them all play on the same team. Thanks to Matter, a device on your Wi-Fi network can now talk seamlessly to a tiny sensor on your Thread network because they're both speaking that same Matter language on top. It's the great unifier. Now, Matter keeps all this organized with a concept called a fabric. And the best way to think about a fabric is like it's your home's own private, secure, smart device club. When you add a new gadget, a process called commissioning gives it the secret handshake, the credentials it needs to join the club and talk securely to all the other members of your home's tech family. So we've got the standard, this awesome universal language called Matter, but how does a physical thing like a light bulb actually speak it? Well, that all comes down to the hardware, the brains of the operation. And for a ton of these new devices, that brain is a powerful little chip called the ESP32C6. This little system on a chip is an absolute game changer, and here's why. It has radios for both Wi-Fi and for IEEE 802.15.4, which is the tech behind Thread. Having both radios on one chip makes it incredibly versatile and super cost-effective for anyone making a Matter device. It can connect however it needs to, all while sipping power. It's kind of the perfect hardware for the job. Okay, so we've got the standard, we've got the hardware. So what's next? How does a developer actually take these two things and build a real product? This is where the Software Development Kit, or SDK, comes in. It's basically the blueprints, the cookbook for creating something with Matter. Now look, the reality is a developer staring at a screen full of commands. But you can really boil that whole journey down to 4 main steps. First, you set up your computer. Second, you grab all the official Matter code. Third, and this is the fun part, you build your app, telling it if it's going to be a light, a lock, or a sensor. And finally, you flash that software onto the ESP32C6 chip. That's the recipe for making a smart device today.
Okay, this next part, this is where the real magic happens. It's not just about getting a chip to power on. It's about building its digital soul, its identity, so that every other device in the world knows exactly what it is and what it can do. And the secret sauce for all of this is something called the Matter data model. Just think of it as the device's digital DNA. It's a universal, standardized dictionary for describing every single thing about it. And because this description is standardized,
any Matter controller from any company can instantly read that DNA and know exactly how to control it.
And this digital DNA isn't just a jumble of code, it's organized really neatly in a simple hierarchy. At the very top, you have the node. That's the physical chip itself. That node can have one or more endpoints. So think of a smart power strip. Each individual socket could be its own endpoint. And then each endpoint is made of standard clusters, which are just prepackaged sets of features, like on-off control or level control for dimming.
And this is what it all boils down to. A developer doesn't have to reinvent the wheel every single time. With just one line of code like this one here, they can basically say, hey, I'm making a color-changing light bulb. And that one command automatically pulls in all those standard clusters, on-off, brightness, color, in a way that every other Matter device just gets. That right there is the power of standardization in action.
All right, so the code's written, it's been flashed onto the chip, the device has its digital DNA. What's the last piece of the puzzle to make it a real working part of your smart home?
That final step is called commissioning. It sounds technical, but it's really just the official welcome party for your new device. It's the secure handshake where your phone or smart speaker adds the device to your home's Matter fabric. It's like welcoming a new member into the family and giving them the keys so they can talk to everyone else. And usually, it's as simple as just scanning a QR code.
And once that handshake is done, the result is just simplicity. It's beautiful. All that complicated networking stuff is hidden away. Whether you use your voice, an app, or some automation, the commands are just direct and reliable. Turn on, change the color, dim to 50%. It just works. Because all that hard translation work has already been done behind the scenes.
So, this is the big takeaway. We started with this huge problem of walled gardens and fragmentation. The solution isn't just some new radio signal, it's a whole new philosophy. It's about a shared, standard data model. By having one common language, every device can finally communicate, which levels the playing field and unlocks, well, endless possibilities for a smart home that actually feels smart.
What all this really means is that the combination of an open standard like Matter and this powerful, super accessible hardware like the ESP32C6, it's completely changed the game. The barrier to entry has just been obliterated. Innovation isn't just for the giant tech companies anymore. So the real question isn't what they're going to make next, now that the tools are available to everyone. What will you create?